Hello everybody, this is Dr. Poti and I will be recording to you dosage calculation. So in this particular problem, as you see, you'll be giving epinephrine 0.5 milligrams sub-Q now. And how many ml will the patient receive? So when you see an order like how many ml will the patient receive, basically that says like how many ml per dose, will you be giving to the patient, right? So just watch out for that verbatim. However, it is asked, all it is asking is, or all the question is asking is how many ml will you draw up or how many milligrams will you administer per dose to the patient. So when you're looking at this problem again, sometimes you may have images like this, or sometimes all these numbers that you need will be embedded in the problem. So when you have an image like this, there will be like probably couple of numbers like this, for example, 1:1,000, but really that doesn't matter to us, right? So what we are like really going to be looking at is, remember, like, our acronym that we were talking about, we said like A, O, and N, right? So in this way, you will be able to just like take the information that you need from the problem that you require to be able to solve it. So when you're looking at this problem available, that means what is it that you have available? Sometimes it will be given in the problem, as I was saying, but sometimes you have to derive the number out of this image that is given to you. So as you look at these numbers, it says like 1 milligram per ml, right? So this is what it is available for you. So that is what you're going to write here. So what you have available is 1 milligram per ml. And what is your order? So your order is 0.5 milligrams sub-Q now, right? So that is what you're going to be giving. So 0.15. So, sorry, 0.15. So 0.15 milligrams. So you'll be having that milligrams, and our inference is per dose, right? So you'll be giving per dose, you'll be giving 0.15 milligrams. And what is it that you need? That means what is it that you need to draw up? So as you look here, it says like how many ml, right? Is that you're going to give. So now, so what is it that you need is how many ml will you drop a dose? That is what it is. So now you have like what is it that is available, what is the order, and what is it that you need. So again, as I was saying, you always like, or if you have a way that is working best for you, I wouldn't say, or I wouldn't recommend like for you to change it. But as always, like, if there is like an easier way that you're looking at, or sometimes in between you're doing the problem, but sometimes if you're getting lost and if you're thinking, is there any other way to do it, then maybe this is what I will advise. So you can always like start by what you need, like ml per dose. Give me 1 second. I'm trying to like really insert a line here so it helps you to understand well. So you always start your problem ml per dose. So there is a reason why you do this. So as I was mentioning in my previous video, so what happens is like, dimensional analysis is a factor method. That means it runs by factors over numbers. So the way you set your problem, basically you will set it like based on the factors. That means like in a zigzag manner, like a numerator or a denominator or a denominator or a numerator, you should be able to cancel out all the factors or the units. So once you cancel all of those out, what is it that you're looking for should be the only one that is remaining. So now you'll be looking for, or you'll be starting your problem with ml per dose, right? So after you cancel off all your units, whatever remaining should be ml per dose. Then that means that you have laid your problem correctly. So over here, ml per dose. So I'm going to start my problem with ml because I want ml in my numerator. And I'm going to look at the problem and see what in the problem has something to do with an ml, right? So over here, I do see that 1 milligram is in 1 ml, right? So that is what I'm going to do. So I'm going to say like 1 ml, right? And then over here, even like, 1 milligram in 1 ml, you can write it like that if you want to, like available, right? Ml is, it's like an inference that it is 1 ml. But if that makes you understand better, all I did is, 1 milligram per ml, right? So rather than just writing 1 milligram per ml, I wrote like 1 milligram per 1 ml. Okay, so because I have ml in the numerator, I'm going to start my problem with an ml. And so what is that 1 ml associated with? So that is what I want, right? So that 1 ml is basically associated with 1 milligram. So that is what I'm going to write here, that 1 ml is associated with 1 milligram. Because I have milligram in the denominator, I'm going to start with milligram in the numerator, so they will be able to cancel out. So I'm going to look through the problem and say what in the problem has something with milligram. So I say 0.15, right? So that is what I'm going to write, 0.15 milligrams. So that, what is that 0.15 milligrams associated with? That is per dose, right? So now I'm going to like do my cancellations. So here I have milligrams. So I'm going to cancel my denominator milligram and the numerator milligram. And what I have remaining is ml per dose. So I need ml per dose, and the units that are remaining are ml per dose for me. So I will multiply everything on the numerator, and then I will divide it by, the answer that I get after I multiply everything in the denominator. So when I multiply all the numerators, it's a very simple problem, right? So I'm going to be getting like 0.15, and in the denominator itself, I have 1. Right? There is not much of multiplication here to do. So that will give me an answer 0.15. And what is that 0.15? The remaining units that I have is ml per dose, right? So this will be my answer. So we will look at like a next problem, which is along the same lines. Okay, so you have flumazenil 0.2 milligrams IV now, and you may repeat 2 times in 1 minute intervals if no response. Then the supply is flumazenil 0.1 milligram per ml. So again, the inference is, if it's a 0.1 milligram per ml, then the inference is it is per 1 ml, right? So in a 5 ml vial, how many milliliters will the patient receive per dose? So when you see problems like this, there is like a lot of wording. And maybe, if you really look at, there may be some numbers that may be distractors, right? Maybe you'll not even need those to solve your problem. So again, going by your AON. So going by your AON, so what is it that is available for you? So I do see that whenever we have a problem like this saying supply is flumazenil 0.1 milligram per 1 ml in a 5 ml vial, I see many of the students like also trying to take this number into consideration and then trying to fit this number somewhere. And then that is kind of like, that will kind of like throw your problem out, right? So when you're looking at problems like this, okay, so what is it that you have available? So available is pretty much like flumazenil 0.1 milligram per ml. This is what is available for you, right? Does it really matter if this concentration is in a 5 ml or a 10 ml or a 15 ml vial? It really doesn't matter, right? So basically, I mean, the quantity really doesn't matter for you. What you need is, what is your concentration? So now available is, obviously it is like 0.1 milligram per ml. This is what is available for you. So that is what you're going to write it here. Okay. Okay, give me 1 second. Okay, the next one is order. So what is the order? So now you're supposed to give 0.2 milligrams IV. Now that means like per dose, right? So you're giving a dose now when you have to give 0.2 milligrams IV now. And also you have some extra wordings here. May repeat 2 times in 1 minute intervals if no response. Do you really need it, right? So sometimes when you have like problems like that, sometimes you may, it may has got something to do with the answer, but in this particular problem, if you really see it, all you need is, you need to give 0.2 milligrams IV now, but it is not asking you any repeat dose or something like that, right? So it is only some information that you're having, so you can safely exclude that information. So your dose that you'll be giving is 0.2 milligrams. So this is your order, right? And so what is it that you need? So you need how many milliliters will the patient receive per dose? So you are looking at your ml per dose. So as I always said, like, you will start your problem with whatever you need. So you're going to be starting your problem with ml per dose. Okay. So now after you cancel out all your units, then this is what should be remaining for you. You should have like this ml per dose that is remaining. So when you look at ml per dose, now you're going to look through the problem and say what in the problem has something to do with ml, right? So now you have like ml, because I'm going to start my problem with ml because I want ml in the numerator after I cancel all my units out. So now it says that, okay, I have like 1 ml. That is what is in my problem, right? Now, what is that 1 ml associated with? That 1 ml is associated with 0.1 milligrams. So that will be my denominator because they're inseparable, right? That 1 ml is associated with that 0. milligrams. Okay, because I have milligrams in my denominator, I'm going to start off with milligrams in my numerator. So again, what in the problem has got to do something with the milligram. So now I see there is like 0.2, right? So I carry my number there, 0.2 milligrams. And what is pretty much that 0.2 milligrams? That is nothing per dose, right? So that is what I want to give per, per this dose. So I'm going to give 0.2 milligrams per dose. So now I'm going to cancel my milligrams in my denominator. 2, I'm going to cancel my milligrams in my numerator. And I have ml here in my numerator, and I have dose in my denominator. So now this is what I'm looking for, right? ml per dose, and I have ml per dose remaining. So now I know that even the way that I set my problem is correct. So now I'm going to do multiplications of my denominator, which is nothing but 0.2. And I'm going to do multiplications of my denominator. Give me 1 second. Okay. Okay. So 0.1. So when I do that particular division, all I will be having is 2 ml. So what is the 2 ml per dose? Right? So now this is my answer. So these are like pretty much simple problems. So now, as of now, over here it is like ml, right? So, and then it says like IV. So just remember that it doesn't matter in your problem. If you know the concept, if you just know how to lay this problem out, you'll really be able to answer any problem. For example, here it says like uh, ml, right, or milligrams. So your answer could be like grams, your answer could be micrograms, right? Or here it says IV, so it could be sub-Q, it could be PO. So really all those doesn't matter as long as you're able to lay your problem out correctly. So we will also look at some of the other problems now. So this is like critical care medications, and this is where I see students like really taking time, uh, because obviously these are like critical care medications, right? So the calculation also is going to be very critical. So again, these problems may appear a little bit longer, and then they may have like various units like micrograms, kilograms. You may see like grams, and you'll see like pounds. So you'll be seeing like various units in this. So again, the principle always remain the same. So you go by what is available, what is your order, and what is it that you need. So as I was saying, in your NCLEX or even in your HESI, you'll be given a scratch paper and also, or like, a small like dry erase board. So make sure that you do use those while you're doing the calculation. So the first thing, as I like, read my problem, I'll just go by like my AON. So I'm going to read through the problem and see. Okay, so I have dobutamine 0.5 micrograms per kilogram per minute. So this is my order. So continuous IV. Patient is 211.86 pounds, or patient weighs, this much of weight. Then the supply is dobutamine concentration 1 milligram per ml. So how many ml do I give? And then round to the nearest tenth. So anytime when you're giving critical care medications, then usually it is going to be round to the nearest tenth unless otherwise it is mentioned. So in your exams, you will be given clear instructions as to how you have to round it. So make sure, like, when you do your problems, make sure that you follow the instructions, because if it says like round to the nearest tenth or round to the nearest hundred, and if you do not follow the instructions, you may get your problem correct, but then the answer is going to be marked as wrong. So as you're reading the problem, so look at the units. What is it you're supposed to do? Do you round it to the nearest whole number, tenth or hundred? So as you look here, so what is it that you have available, right? So uh, now it says like the dobutamine concentration is 1 milligram per ml. So this is what you have available, right? So that is what I'm going to write, 1 milligram, 1 milligram per 1 ml. So this is my concentration that is available for me. And the next one is, what is my order, right? So my order says 0.5 micrograms per kilogram per minute. So that is what I'm going to write here. 0.5 micrograms per kilogram per minute. And what is it that I need? So I need to, basically I'm setting my pump. So how many ml per hour? So this is what I need. So as always, I'm going to start my problem with what is it that I need. So ml per hour. So in these problems, just kindly bear with me because these are like longer problems and it just takes time for me to really insert these lines. So this is what I need. So ml per hour. So when I say that ml per hour, now I'm going to start off my problem with ml. Okay, I'm just going to put this red so you don't get confused, because this is what we need and this is what we are looking for, right? So, okay, so now I'm going to start my problem with ml. So I'm going to look in the problem to see, okay, what in the problem has something to do with ml. So I see like my available dose has ml unit in it. And what is that 1 ml? What is that associated with? That is associated with 1 milligram, right? So now I'm going to like have that 1 ml And then I'm going to have 1 milligram here. Now, because I have my milligrams in my denominator, I want to start my problem with milligrams in my numerator. So I'm going to look in the problem to see, is there anything with the milligrams? But really, I don't have anything else with the milligrams, right? So, but I have micrograms, like, which is very close, right? So now I'm going to use this as a conversion factor because I have my medication as milligrams, but I will be giving it as a microgram. So now I'm going to use my conversion factor. So now I'm going to say, okay, 1 milligram is equal to 1000 micrograms, right? So that is what I'm going to do. So I'm going to say, okay, 1 milligram is equal to 1000 micrograms. Now, because I have micrograms in my denominator, I'm going to start off my problem with micrograms in my numerator. So I'm going to see, okay, what in the problem has micrograms? It is 0.5, right? So I have 0.5. So what is that 0.5 micrograms associated with? So as I look in the problem, that 0.5 micrograms is associated with kilograms per minute. That means you're going to give 0.5 micrograms of medicine per every kilogram per minute. Okay, so you're going to separate the medicine that you're going to give, and also you're going to separate the features, like, okay, so you're going to give 0.5 micrograms of medicine for what? For every kilogram of the patient per every minute, right? So now I have kilograms here, but towards the end, like eventually I need to have ml per hour. So my kilograms, I know that it has to get canceled out. So I'm going to have kilograms in my numerator. So, but then there is nothing like close to kilograms here, right? But I have something with pounds. So now I'm going to use this as a conversion factor. So now I'm going to say, okay, 1 kilogram is equal to 2.2 pounds, right? Now I have pounds in my denominator. So I'm going to start off with my pounds in my numerator. So I see like 211.86. So I'm going to put my numbers there. Give me 1 second. Yeah, when we have like longer numbers, it's just going to, trip us and then make another sentence. I'm trying to avoid that. Okay, so you have pounds in your denominator. So I'm going to have pounds in my numerator. And now I have like 211.86. Pounds, right? And then I have 211.86 pounds, but what is that associated with? Really nothing, right? So I'm just going to use 1 as my placeholder. Now I have minutes here, but I need to have my, my pump set in hours. So I'm going to use the conversion factor again. So I'm going to say, so I'm going to use my minutes. Give me 1 second, please. Okay. So I'm going to have my minutes in my numerator because I want to be able to cancel out. And then I'm going to use this as a conversion. So 60 minutes is equal to 1 hour. Right? And now I have used up all the numbers. Like when you like really, when you check it, you have used up like your, sorry. Okay, you have used up your this particular number 0.5 micrograms per kilograms per minute. You have used up your pounds, and you have used up your concentration, right? So you have pretty much like used whatever numbers that are required, you have used them up in this particular problem. So again, to just give you an overview, so you read your problem first, and then you start off with your AON. What is it that you have available? What is the order? And what is it that you need? So when you're looking at what is that is available, it is your concentration. So you have 1 milligram per 1 ml. That is your concentration. And your order is 0.5 micrograms per kilogram per minute. That is your order. What is it that you need? You need mLs per hour. So that is what you're going to write down. And you're going to start your problem with ml per hour because that is what you need. So after you cancel off all the units, you need to have ml per hour remaining. So when you look at your problem, what is it that can have or that has ml, right? So now you have like 1 milligram per 1 ml. So you're going to start your problem with what you need. So the numerator of what you need, which is ml, and you're going to plug in those numbers. So as you plug in those numbers, okay, 1 ml, it has 1 milligram. Because you have milligram in the denominator, you're going to have milligram in your numerator. So you will start off with milligram in the numerator, but there is nothing with milligram in your problem. So you will use it as a conversion factor because you have micrograms, right? So 0.5 micrograms. So you're going to use it as a conversion. So 1 milligram is 1000 micrograms. And because you have 1000 micrograms here, you have micrograms. So you're going to start your problem in your numerator with micrograms, and you have 0.5. And that 0.5 micrograms is associated with kilograms per minute, which is going to be your denominator. Now, your patient weighs in pounds, you have kilograms. So you're going to use a conversion factor. 1 kilogram is 2.2 pounds. And because you have pounds in the denominator, you will have pounds in the numerator, which is your patient's weight, right? And again, you have like minutes remaining, but you need hours. So you need to use like another conversion factor, which is 60 minutes, right, is equal to 1 hour. So after you lay your problem out, now you start like you're canceling out, okay? So this is the interesting part. As I was saying, once you cancel out everything, if you do not get what you're looking for, then that means don't even bother to like really do the calculations because your calculations are going to be wrong. So let's see if we will have ml per hour remaining. So you canceled out your milligrams and milligrams, you cancel out your micrograms. So over here, you're canceling out your units, okay? You're not doing anything with the numbers yet. You're only canceling out the units. So you have kilograms in the denominator. Numerator. You have pounds in the denominator. You have pounds in the numerator. You have minutes in the denominator. You have minutes in the numerator. So you didn't do anything with the numbers at all. All you did was basically cancel out the units. So let's see what you have remaining. You have ml. And you have hours remaining, right? And this is what you need. So now you laid your problem correctly. So now you can do the multiplication. So when you're doing multiplications, you can cancel the zeros out if you would like, or you can just like, multiply everything. So here I just cancel like the 1 0 that I had. So now you're going to multiply everything that is in the numerator, like 0.5 times 211.86 times 6, right? So you're going to multiply all of those. So you'll be getting 635.58. And when you multiply everything in the denominator, you will be getting 220. So once you do that calculation, you will get 2.28. And because you have to round it to the nearest tenth, you will get 2.9. And what are the units? ml per hour. So your answer will be 2.9 ml per hour. So let's look at another problem of a similar kind. So the order, again, it says start dopamine 2 mics per kilogram per minute, continuous IV, and titrate until systolic is above 90. Patient weighs 174.9 pounds and supply is dopamine 200 milligrams in 100 ml of 5% dextrose. How many ml do you start with? Round to the nearest tenth. So again, as you're reading this problem itself, there is a scenario that is given to you, right? They're asking you, okay, you have to start this medication, you have to maintain the systolic greater than 90 mm of Hg, and then the patient weighs 174.9 pounds, and then the supply is 200 milligrams in 100 ml of 5% dextrose, right? So again, you go by available. What is it that is available, what is the order, and what is it that you need. So as you're looking at the problem itself, what is it that is available for you, right? You have 200 milligrams in 100 ml, right? So then that is what you do. Okay, you have 200 milligrams in 100 ml. That is what is available for you. What is the order? It says 2 micrograms per kilogram per minute, right? So 2 micrograms per kilogram per minute. And then what is it that you need? Again, ml per hour. So this is how you have to start your problem, right? So ml per hour. So again, when you're starting your problem, as always or as before, start your problem with what is it that you need, right? So you're going to start your problem with what is it that you need, which is nothing but your ml per hour. So that means like your numerator should be ml. So this is what you'll need. So I'm just going to make it red so you don't get confused. So you need to start your problem with ml. So when you cancel out everything, then you will be having, you'll have like ml per hour remaining. So as you look at this problem again, there are like certain numbers, like, maintain the systolic above 90 mm of Hg, right? So really, do we really need that? Right? So sometimes, like, when you see the numbers, don't try to fit in the numbers somewhere in the problem, because that is not how it is supposed to be, right? So just be very focused. So, and also you see like 200 milligrams in 100 milliliters of 5% dextrose. So really, does this matter if this medication is in 5% dextrose, or if it is in 0.9, or if it is in 0.229? It really doesn't matter to us, right? So this is what, so all we need is like, what is the concentration? It really doesn't matter in what it is mixed. Okay. So now you start your problem with ml. So what in the problem has something with ml? Okay, sorry, over here, it is like 200 milligrams in 100 ml. Okay, so as you look at the problem itself, what in the problem has ml? Okay, I see like 100 ml here, right? So now I'm going to do that 100 ml. So what is that 100 ml associated with? So that 100 ml is basically associated with your medication, right? So it is associated with your 200 milligrams of the medication itself. Now, because you have milligrams, again, like, in the denominator, you're going to start your problem with you're going to start the next step with milligrams in the numerator. But you do not have anything with the milligrams, but you know that you will be giving your medication in micrograms. So again, you will use this as a conversion factor. So now you will say, okay, 1 milligram is equal to 1000 micrograms. Give me 1 second. My Word document is a little bit slow today. Okay, so I'm going to say, okay, 1 milligram is 1000 micrograms, right? So now again, because I have micrograms in my denominator, I'm going to have micrograms in my numerator. And when I look at the problem itself, I know that it is like 2 micrograms because this is what I'm supposed to give, right? 2 micrograms per kilogram per minute. So I'm going to have 2 micrograms here. And what is the 2 micrograms associated with? The 2 micrograms is associated with kilograms per minute. So I'm going to have my kilograms per minute in my denominator. Right? And I know that when I look at my problem, I do not have anything close to kilograms, but I have something with pounds. So now I'm going to use, because I have kilograms in my denominator, I'm going to start with kilograms in my numerator. So when I look at my problem, I do not have anything with the kilograms, but I have with pounds. So I'm going to use this as a conversion factor. So 1 kilogram is equal to 2.2 pounds, right? So because I have pounds in my denominator, I'm going to start off with pounds in my numerator. And my patient's weight is 174.9 pounds, right? And so on my denominator, I'm just going to use 1 as a placeholder because it doesn't change any value. So I need to set my pump in hours, but I have in minutes. So now I am also going to use the next step as my conversion factor, right? So now I'm going to say, okay, 60 minutes is equal to 1 hour. So I'm going to say 60 minutes is equal to 1 hour. Right? So now when I look at the problem, I pretty much have used up all my numbers and I pretty much used up all my units. So again, as you're looking at this problem, you read through the problem first and then you write your AO and what is it that is available, what is the order and what is it that you need. And then you start with what you need, okay, ml per hour. And then you're going to be looking at, or you'll be starting off with ml first, right? And then you kind of like look at the problem to see what is the number that correlates with the ml. And that is how you're going to lay your problem out. So here you have like milligrams in the denominator. So you're going to cancel with the milligrams in the numerator. You have micrograms in the denominator. So you'll cancel with micrograms in the numerator. Now you have kilograms in the denominator. You have kilograms in the numerator. You have minutes in the denominator, which will cancel with minutes in the numerator. You have pounds in the denominator, which will cancel with pounds in the numerator. So again, you're only canceling the units, but you're not doing anything with the numbers. Okay, so now you have canceled everything, and now you see whether whatever units are remaining is what you're looking for. So now you have ml which is remaining and you have hours which is remaining, right? So now you know that this is what you're looking for, ml per hour, and you have ml per hour. That means you laid your problem correctly. Just say that after you cancel the units, you may just have like remaining, maybe you say, in numerator you have milligrams and in denominator you have like minutes or pounds. So really, that means that even the way that you laid your problem is not correct, right? So now you have ml per hour, which is remaining. So that is like great, right? So this is your problem is correct. So you can multiply everything in the numerator and then everything in the denominator and then divide them, or you can cancel the zeros. So here I'm just going to cancel the zeros. I have two zeros in my numerator, two zeros in my denominator. So I have like a zero here and I have like another zero here. Okay, and now I'm going to multiply all the remaining numbers. So when I do that, my numerator, I'll be getting 2098.8, and my denominator, I have 440. So when I divide that, I'm going to get 4.77, right? And then because I have to round it to the nearest 10th, I will get 4.8 and 4.8 ml per hour. That is what was remaining, right? 4.8 ml per hour. So this is how I set my pump. So hope this was helpful to you a little bit. So make sure that you do practice many of these questions. Again, dimensional analysis is something that you have to practice. So make sure that you practice it. And always, if you have any questions, you can always reach out to me. I'll also be making another video with some of the other problems. For example, we'll be looking at heparins and some of the other IV fluids. Okay, so for now, continue practicing. And if there is anything, please do let me know if you have any questions. Best wishes, everybody.